Hello, welcome to the session of Automate High Availability Setup in RDS Custom for Oracle. In this session, we will talk about an automated solution by which you can deploy the HA setup for RDS Custom for Oracle using AWS CloudFormation and AWS System Manager documents. I am Arnab Saha. I work as a database specialist partner solutions architect here at AWS. I primarily specialize on RDS Aurora and the migration services. I help the AWS partner in their cloud modernization and the data migration journey. Today, I have my colleagues Sharat Chandra Kampili and Yamuna Palasamudram along with me as a part of this presentation. Sharat and Yamuna, would you like to introduce yourself?
Thank you, Arnab. Hello, everyone. We are delighted to welcome you all here for this informative session. Your presence is greatly appreciated, and we are excited to share valuable insights and knowledge with you. To introduce myself, I am Sharat Chandra Kampili, a database specialist solution architect with AWS, and mainly focusing on RDS workloads. I have been with AWS for close to 3.5 years now, and I am based out of Dallas, Texas. I have over 13 years of experience in the industry, mainly on Oracle databases as DBA and across multiple industry verticals. Along with me, I have Yamuna. Yamuna, can you please introduce yourself?
Thank you, Sharat. Thank you, Arnab. Hello, everyone. My name is Yamuna Palasamudram, and I'm a senior database specialist solutions architect. Been with AWS for over 2.5 years now, and I am based out of Windy City, Chicago. I have over 18 years of experience working in the industry, mainly with Oracle databases and other Oracle technologies like Oracle Apps, Fusion Middleware, identity and management solutions across various industry verticals. The most I enjoy being in this role is the opportunity I get to talk to my customers, understand their challenges and pain points as they deploy AWS services in their for their environments. And today's session is very closely related to that. It is to address one such challenge. And I'm really excited to be here talking to you about a new solution that we have built, which will help automate the entire high availability setup for running your Oracle databases in Amazon RDS Custom for Oracle. Now, with that said, let's get into the session. A brief agenda for today's video. Let's begin with an overview about Amazon RDS Custom for Oracle service. And then I would like to provide context around why we came up with this solution, how it will help the customers and the use case for this particular solution. And then I'll get into the actual architecture for the solution itself. And then Arnab will take over and he will talk about the technical details on how we have built this solution and also the high-level deployment steps. It will then be followed by a demo by Sharat, and we will conclude with summarizing what this solution does, how it can help you, and we'll also share some resources at the end. Most of you here, I'm assuming, are already aware about Amazon's managed database service called Relational Database Service, or RDS. RDS is available for a variety of database engines like open source engines like PostgreSQL, MySQL, MariaDB. We have our own Aurora database service, which is also available for Postgres and MySQL. RDS is also supports commercial engines like Oracle and SQL Server. Now, Amazon RDS Custom is a newer service under the umbrella of RDS services, and this is available only for commercial engines like Oracle and SQL Server. RDS Custom is also a managed database service for legacy, custom, and packaged applications that require access to the underlying operating system and database environments. Now, for applications such as Oracle's eBusiness Suite or other custom packaged applications, RDS Custom gives you that flexibility as well as additional privileges to support these custom apps, and as well as having third-party applications and agents on the database host itself. RDS Custom automates the setup, operation and scaling of databases in the cloud while granting access to the database and underlying operating system to configure, customize settings, install drivers, enable native features to meet the dependent applications requirements. Now, this is kind of a blend. You get the benefits of a managed service, but you also get the flexibility. You can get the managed features like easy provisioning, setups, scaling, automated backups. So it is kind of easy for you to set up and manage and operate, but also get flexibility. So you can use your other custom applications as needed. Now, just taking a step back, there are various options for you to deploy your Oracle databases on AWS. Now, just to elaborate on that, now if you're running your databases on premises, you as customer, you're responsible for procuring the hardware, the entire data center setup, networking, cable installation, and so on. And then on top of that comes the operating system installs, patching the OS, and then the database software installs and setups, and then the backups, high availability setups, scaling, application optimization, and so on. Now, in AWS, you have broadly 3 ways that you can deploy your Oracle workloads. Now, the first one is you can have your Oracle workloads on EC2, which is our Elastic Compute Cloud. Now, with this, you use the AWS networking and now with this option, you basically use the underlying infrastructure provided by AWS, and then all the other tasks about that, right from your operating systems to databases and setups, is something that you're responsible for. And we call this as the self-managed option, right? Because you're responsible for most of it. And then comes our relational database service, or RDS. And in this, AWS manages almost everything for you, right? You use the infrastructure, you use the networking, the operating system, database installation, patching, scaling, backups, high availability. Now, all these are provided as a managed feature for you. So that you don't have to worry about the heavy lifting part of running databases, and all you have to think about is the application aspect of it. Think about tuning and optimizing your application for better efficiency and meeting your business requirements. Now, we highly recommend to go with RDS for as your first choice, because it just takes care of all the undifferentiated heavy lifting and you get the most benefits out of it. But there are some cases which are not covered or supported with RDS, where the application would need additional privileges either to the database or to the operating system. Now, to meet those specific use cases, we introduced Amazon RDS Custom for Oracle. And like I mentioned, this gives the benefits of managed service, but also gives more flexibility to the database and operating system itself. Now, because of this additional access, there is also a little more added responsibility in case of RDS Custom for Oracle. Now, today's session will be focused on Amazon RDS Custom for Oracle, and specifically we will talk about high availability for running databases on Custom for Oracle. Now, just to give a background on, how and why we came up with this solution. Now, as we talk to our customers and help them through their architecture design phase, now the most common or the top requirement for any application, any customer, is high availability. Now, today RDS Custom, like I mentioned, gives you that flexibility. Customers can set up high availability disaster recovery configuration as per their needs. You can use your own way of setting up that HA to meet the RPO and RTO requirements as per your application needs. But what we heard from our customers as a top concern is the complexity of setting up the HA configurations manually. So it can be time consuming, especially when you have to do this for a fleet of databases. It can also be cumbersome, it is prone to errors, and that is where customers were finding it challenging to kind of go through this HA setup manually. And as a result of that, we built this solution to help our customers to easily set up high availability for Oracle databases. Now, the architecture that you see here in the screen is what we have built. Now, the underlying technology for this entire HA setup is Oracle's Data Guard along with Fast Start Failover. Now, just as a quick refresher, let's go through some of these terminologies here. Like you all know, Fast Start Failover builds upon features such as Oracle's Data Guard, Flashback Database, and Data Guard Broker. The foundation for FSFO is Data Guard, a primary database, and at least one standby. The standby can be physical or logical. There can be multiple standbys as well, but only one of the standby can be a failover target at any given time. In maximum availability mode, FSFO guarantees that no transaction that has received a commit acknowledgement will be lost during a failover. The price for this guarantee is increased commit latency. Now, when we set up for maximum availability mode, it means that it is doing a synchronous redo transfer. Now, although redo transfer is synchronous, maximum availability mode allows the primary to remain available if the standby becomes unavailable for any reason, maybe a host or a network failure. Um, if the primary is unable to contact the standby after a user specified period of time, it drops out of synchronous transfer mode and begins operating as though it were in the maximum performance mode. And when the standby becomes available again, the primary and standby resynchronize and resume that synchronous redo transfer. And then there is an observer. Observer is a process that monitors the data guard configuration to initiate an automated failover if conditions warrant for it. The observer's primary job is to perform a failover. Now, only the observer can initiate a FSFO failover in this configuration, and its secondary job is to automatically reinstate a failed primary as a standby if flashback database is enabled. Now in this particular architecture, now we have a RDS Custom for Oracle primary instance in one availability zone or AZ1, and we will create a read replica in a second availability zone or AZ2, which will act as the data guard standby. Now read replica is just a single API call, so you're using the managed feature, the read replica, and beneath the layer it is using Oracle data guard for setting up the standby. Now we will set up synchronous replication between the primary and standby. Now one call out here is when a read replica is set up, by default it always uses asynchronous replication with maximum performance mode. Now for this solution we will make changes to the DG configuration. We will set up synchronous replication. Again, this is to ensure an RPO of 0. And then we will install and configure a data guard observer process on an EC2 instance in a third availability zone, preferably, but this is not a requirement. This will observe and monitor the primary and standby for any failure. We are also using additional supporting services like S3 to store the Oracle client media, then CloudFormation templates, SSM documents, which is the system manager documents, and IAM roles. This whole solution is a single CFN script, CloudFormation script, that is available to you, which you can use to set up the entire HA for your primary Oracle database instance. We use a single CFN script and use SSM documents within that to perform all the database level tasks, such as making all the data guard configuration changes, setting up fast start failover, and so on. Now in this particular setup, because of the maximum availability mode, we are setting up this entire thing in one region and within the same VPC. And another call out is we are not doing an SSH into the primary or the secondary for making any of these changes, right? We are creating this new EC2 instance, setting up as the observer, and all the changes are made, all the configuration changes that we do are done from this EC2 instance. We are never directly SSHing into the primary or the secondary. I will now hand it over to Arnab to go over the deployment steps for the solution.
Thank you, Yamuna. Let's talk about the high-level step as a part of the installation process. First, I will focus on the prerequisite. The first prerequisite, you should have a primary RDS Custom for Oracle DB instance up and running prior to using this solution. The second prereq is you need to provide the Oracle client media for observer installation as per the bring your own media model. Now in this solution, we provide a CloudFormation template that takes a minimum input parameter from the user and performs a high-level task. Number 1, it provisions an EC2 instance that acts as the data guard observer instance. Second, it will copy the Oracle client media provided by you in an S3 bucket into the observer instance. It will install the Oracle client on the observer instance. Next, it will provision an RDS Custom for Oracle read replica, which acts as the standby DB instance. It will create the tnsnum.oda file and it will add the primary and the standby database entries. It will verify the connection to the primary and standby database from the observer instance, and it will create an wallet to store the data guard user password. Next, it will make all the configuration changes related to the data guard. It will change the protection mode to maximum availability. It will set the lock transport to fast sync, which will configure the redo transport using sync and no AFAM. And it will set the fast start failover target to the standby instance and the fast start failover threshold to 45 seconds. Next, it will start the data guard observer process. Now you can deploy this solution very easily. You can use this solution using the AWS Management Console, or you can run it via AWS CLI. To deploy the solution in your account, you need to complete the following steps. You can clone the GitHub repository to your local machine, or you can download the script from AWS samples. You need to follow the GitHub README to verify the prerequisite and deploy the CloudFormation stack. Next, you need to verify the completion of the stack deployment. Usually the deployment takes an hour, primarily for creating the replica using the RDS API, but also the duration is dependent on the database size as well. So when you start deploying the solution, it will ask you for the 7 existing parameters. It will ask for the VPC ID, the primary or the existing instance ID, the S3 bucket name, from where the media will be downloaded, the subnet for the EC2 observer, the security group for the EC2 observer, and the AZ, the availability zone for the read replica and the observer instance. And you also need to provide one parameter for the Oracle read replica as well. So once you provide all this information to the CloudFormation template, you will be able to see the following resources deployed in your account. You will see one new IAM role, the RDS Custom for Oracle read replica, the EC2 instance, which is a T3 medium, and that EC2 instance will having the Oracle client installed and it is configured with the data guard configurations. Next, I will invite Sharath to show us a demonstration of how easy it is to install this particular automated HS solution.
Thank you, Arnab. Now, let's quickly start with the demo. Before this, Yamini and Arnab has gone through all the components involved in deploying a high availability solution for RDS Custom for Oracle. And also, they discussed on the prerequisites need to meet for this deployment. Let us see them in action. This demo agenda includes deploying the CFN stack, overview of high-level steps in CFN template, validation of CFN stack, trigger a failure, and lastly, validate failover for this deployment. As stated in the previous slide, firstly, customer need to have an existing RDS Custom for Oracle instance, which acts as a primary instance. Let's quickly go to the AWS console and go to RDS service. Here, you can see custom-primary database identifier. When you click on it, you can see networking and security tabs where we will be leveraging throughout the demo. And also, customer has to provide an Oracle client media for EC2 Observer Oracle client installation as per the bring your own media model in the S3 bucket. Let's quickly go to the S3 service. Here, I am using the same CEB S3 bucket used for CEB creation. You can also use the different S3 bucket depending upon your use case. Automation will fetch the Oracle client media from the S3 for installation on the EC2 instance. I can also verify Oracle Client Media exists in this S3. Once we meet the prerequisites, let's switch to the CloudFormation service and proceed further on deploying the solution. Now let's go to create stack with new resources, upload the template which is downloaded from the GitHub, and click on next. Here, we will provide a unique stack name within the region and provide the parameters for deploying the solution. First, we will get the existing environment parameters from the primary instance. Let's first get the VPC ID from the RDS primary instance. And here you can copy the VPC ID from the RDS primary instance and go to CloudFormation template and provide the parameter. And here you'll be providing customer-primary as RDS source DB instance identifier. And we'll go back to the S3 service and copy the S3 bucket name. Provide the parameter here, the S3 bucket. And we'll leave the latest AMI IDs as it is, which is used for the EC2 instance creation. Now let's get the subnet ID. For the EC2 instance observer and then paste it here. And also we'll try to get the EC2 security group. For the case of simplicity, we are using the same security group for all the resources here in this table. Let's go back to the RDS instance and get the security group. And provide the parameter in the EC2 security group. And as you have seen or noticed, the AZ was a 3A and we are providing a 3B here for the secondary instance. And for the RDS custom instance profile, we'll go back to the RDS and fetch the instance profile here in this region and provide it in the parameter. And now provide the target DB instance custom-standby and click on next. Here are the different parameters. Depending upon the use case, you can definitely choose a couple of them. Here we are leaving it as it is and clicking on next. And you can verify all the parameters that you have supplied for this CFN template. And you can scroll down to acknowledge the IAM resources and click on submit. And once submitted, this stack takes at least an hour to deploy because the RDS custom for Oracle replica takes at least 45 minutes to create. Okay. Now I will fast forward into the creation complete. Now you can see all the resources has been created. Let me go through some of the resources and show you the content for this deployment. Here is the EC2 instance which acts as an observer for both primary and standby. And also we have 4 SM documents which helps to set up all the steps involved in successfully deploying the HA solution, like DGMGRL, which is used to set up the data guard setup in the observer, and we have DNS names and wallet, which is used for the complete observer setup to connect to the primary and standby. And also we have a couple of IAM roles which supports the deployment with different services. We also have a Lambda function which will help to execute the SM documents and also validate the execution with the output using Python code. Now, let's go to the EC2 instance and check some of the logs used for troubleshooting and also understand about the deployment process. The key point here is the solution doesn't do any SH to the customer instances. It connects with the RDS_data guard user from the EC2 observer instance and check the connectivity and perform all the operations including enabling fast failover process, starting observer and connectivity with the primary and standby, etc. Now, let's do a sudo to EC2 user and check the data in the EC2 observer instance. And do ls. Here you can find the Oracle client has been installed and there's AWS CLI installed, and we have ORA inventory, logs, and observer log. Let's do a CD to the logs to understand the log structure. Here, the first log, it talks about the complete user data execution statements when we are creating the EC2 user, and the bootstrap actual log that we have used for it. And there are different other logs like TS names, wallet, and DGMGL log. Let's do a cat for that bootstrap log to understand. Here you can see we're installing the AWS CLI version and the necessary packages for this script. And also we are checking the bucket status. We are copying or downloading the Oracle client to the EC2 observer, and we are installing the Oracle client software and dependency packages for the Oracle client software. And also we have a client home path, wallet path, and backup path, etc. Let's go back to the other directory and verify or tail or cat the observer log to understand which is primary and standby. Here you can see ORCL underscore is a primary database, and the FSO for target standby is ORCL underscore B. Let's trigger a failure by stopping the instance. Let me go back to the RDS instance, find the SOS ID in the configuration tab. Now, let's go back to the EC2 instance or open the EC2 instance service. And search for the resource ID. And here you can see the resource ID. And now click on it and go to instance state and stop the instance. This will trigger a failure. And immediately let's go to the observer log, and you can see it has triggered a failure and primary database cannot be reached. And also you can see the failover has been successfully started to ORCL underscore B. The fast failover threshold has been expired, which we have declared as 45 seconds. Now you can see the failover succeeded. New primary is ORCL underscore B. Primary data has changed to ORCL underscore B. Now you can see the fast failover was successful in the log. Let's go back to the console and show you how the failover is replicated on the roles of the instances. When you refresh, you'll be seeing the custom-standby is in the primary role and the custom-primary is on the replica role. This is how, with a single click solution, you can deploy the HA automation using CFN template and make the manual process of different steps to completely automate. Just to wrap up with a few more things, from the cost perspective, when you use this solution, it's pretty straightforward. We are going to create a replica which will act as a standby. So there is going to be a replica instance cost. And also, since we are using this replica, in addition to the enterprise edition license, you also need to have active data license on top of it. And then finally, the EC2 instance itself. Since we are spinning up a new EC2 instance for the observer process, so there will be a EC2 instance cost for the solution. Just another column. If you are just testing the solution in either dev or testing environment, if you don't need it, then you can also go ahead and delete the stack so that it won't be charged for any of the resources. And from the deletion perspective, in the AWS CloudFormation script, we have enabled the deletion protection for certain resources like replica, instances, etc. This is again just to ensure that there is no accidental deletion, but these are on configurable parameters. If you want to delete, you can delete everything. You can just disable the delete protection and you can delete the entire stack. So it's just a follow that if you want to delete the stack, which is completely possible. Now, let's discuss about current limitations in this version of the script. The first one, when you use a script for your setup, there is any failure on the primary and the fast failover performs the particular failover to the standby database. The endpoint of the new primary will be different than the old primary. So, as part of this particular CloudFormation template, we are not doing any automatic CNAME change. So, whenever a failover happens, you have to point your application to the new endpoint. Now, this can be set up manually. And also, we know a lot of customers use this type of configuration today. Mostly, many of them use Route 53 for the CNAME field. So, you can have your database trigger, which kind of changes this Route 53 CNAME field from old primary to the new primary. It basically triggers based on that failover from primary to standby database. This is possible. It's just not included in this version of the script. And we are just setting up a single EC2 instance for the observer. And let's assume there is a failure on the EC2 instance itself or on that particular ESE. Then you have to use a snapshot restored for that EC2 to start up the observer. So as of now, for this version, we don't have any high availability for the observer piece itself. And we have tested the solution mainly on the database 19c version because this is the version mostly used by many of the customers. And lastly, about the flashback. So whenever a failover happens from primary to standby, the observer can reinstate the old primary and make it new standby only if a flashback database is enabled. So if it is not enabled, then you have to rebuild your old primary to make it as a new standby. Now as part of the script, we have not enabled. We have not included the flashback enable. But in our blog post and the readme, including this description of the video, we have called out and provided the options to customers to enable the flashback feature. And we recommend to use flashback database whenever you're using this type of FSFO or fast failover server configuration. Summary. So we do have this particular solution published as a blog post, and there is a GitHub repository mentioned in the blog post. And also we published the solution as a AWS solution guidance. You can find them in the description of this video. And as an open source solution, it can be tweaked as per your needs. Lastly, please reach out to your respective account team to get more understanding about the solution. We will be happy to help you. And also, we have included few other resources, and these are really helpful with the content that is available, and mainly around on performing a lot of automation at the OS level as well as the database level tasks on RDS custom instances. And we have used the same concept here in this solution. That was the demo we have showed you today. Today, we have reviewed the availability of RDS Custom for Oracle and how we can automate it to offload the heavy lifting. Thank you so much for taking the time to go through this video. I hope this was very helpful and you will be able to apply what you have learned today to your own environments. Enjoy the rest of your day. As always, wish you happy cloud computing from everyone here at AWS.